To find the zeros of a polynomial function is the same strategy as finding the horizontal intercepts. To find zeros, we need to do a solve. We need to solve when is our function equal to 0. So in this particular function, we have a couple of choices. So if we're looking at when is x squared minus 4x plus 13 equal to 0, the first thing we can always look to see is, can we use our factoring strategy? To do this, we would need two numbers that multiply to positive 13 and add to negative 4. Since the only things that multiply to 13 are 1 and 13, it's not possible to factor. So we need to head to one of our other strategies. Let's look at how we could solve this using our strategy to complete the square. So if we're completing the square, I'm going to start by moving my constant of 13 over to the other side. So I have x squared minus 4x now equal to a negative 13. So I want to find the perfect constant to fill in that spot. So we take a look at the number that's in front of their x term. So in this case, it's a negative 4. So we need to divide by 2. Negative 4 divided by 2 is negative 2. And then take that negative 2 and square it. Negative 2 squared is a positive 4. So I'm going to add 4 on the left and then also add 4 on the right-hand side. Now the left-hand side of this equation can be factored. Think about numbers that multiply to positive 4 and add to negative 4. We can factor this as x minus 2 times x minus 2, or that would be easier to go ahead and just write that as x minus 2 squared. Go ahead and add those constants together from the other side. Negative 13 plus 4 is negative 9. We're ready at this point to use our square root property. So the square root of x minus 2 squared is going to be plus or minus the square root of negative 9. So the squared and the squared cancel out, leaving x minus 2. When we're thinking about the square root of negative 9, think about the negative separately. So think of this as the square root of negative 1 times the square root of 9. The square root of negative 1 by definition is equal to I, our imaginary unit. The square root of 9 is 3. So we have plus or minus 3i. Finish solving for x by adding 2 to both sides. So x is equal to 2 plus or minus 3i. So these are the two zeros of this polynomial function. These are both complex zeros. So there are no real zeros, which means that the graph of this quadratic function has no horizontal intercepts. Let's look at another option for solving. So if we wanted to solve x squared minus 4x plus 13 equals 0, our other choice, rather than completing the square, would also to be use our quadratic formula. So if we're using our quadratic formula here, a is equal to 1, b is equal to negative 4, and c is equal to 13. So remember, our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We need to plug in and then simplify. So the opposite of negative 4 is positive 4, plus or minus the square root of b squared, so negative 4 squared minus 4 times 1 times 13, all divided by 2 times a, so 2 times 1. So keep going to simplify. Underneath your square root, we've got negative 4 squared, which is a positive 16, minus a 4 times 1 times 13, so minus 52, all over 2. If we keep simplifying, 16 minus 52 underneath our square root is a negative 36, all over 2. So thinking about the square root of negative 36, think of this as the square root of negative 1 times the square root of 36. And we know that 36 is 6 times 6, so the square root of 36 is just 6. So this simplifies to 4 plus or minus 6i all over 2. We can still keep simplifying. Each of those terms on top is being divided by that 2 that's on the bottom. So 4 divided by 2 is 2, plus or minus 6i divided by 2 gives us 3i. Same zeros that we found when we used completing the square, just a different strategy for coming up with those. Take a minute and try to graph this original function. Take a look at the graph on your calculator or on Desmos and look at how the vertex is up above the x-axis and it opens facing upward. So you see a parabola that looks something kind of like this. So it has no horizontal intercepts. This is why we have no real zeros. So both of our zeros, 2 plus 3i and 2 minus 3i, are complex zeros. So with no real zeros, we have no horizontal intercepts.